Deep under the sea, hidden from our sight, an underwater volcano is rumbling to life. Pressure builds within its fiery heart, threatening to shatter the surrounding ocean floor. As the intensity rises, so does the danger. When the volcano erupts, what follows could be catastrophic. Just ask the people of Greece or the Caribbean island of Bermuda. But this danger is not just lurking in remote locations. These powerful events can happen anywhere. There are volcanoes, even where you least expect them, like off the coast of California. The region is home to one of the largest submarine volcanoes on Earth. Here, 32 miles beneath the Pacific Ocean's surface, sits the monster of Monterey Canyon, an underwater giant that has been quietly growing for millions of years. The danger posed by these underwater behemoths cannot be overstated. Take, for example, the Krakatoa, Indonesia, which was once the world's most densely populated island. In August of 1883, the island was rocked by a series of explosions so powerful they could be heard 2,000 miles away. The first eruption was so intense it registered as a 7 on the Volcanic Explosivity Index, the second highest rating possible. The Krakatoa eruption resulted in the deaths of more than 36,000 people and is now considered the deadliest volcanic eruption in recorded human history. Even more recently, in 2021, the Tonga Ha'apai volcano erupted in the Pacific Ocean near Tonga. It was the largest eruption in the world in 3 decades, sending tsunami waves crashing into the islands. Homes were destroyed, crops were decimated, and the country's economy took a massive hit. The eruption even managed to break a submarine communications cable, cutting off Tonga from the rest of the world for weeks. These events serve as stark reminders of the explosive forces that lie beneath the waves. But what makes underwater volcanoes so dangerous? And why should we care about them? Well, let's start with the basics. What exactly is a submarine volcano? Well, just like their above-water cousins, these volcanoes are formed by the buildup of molten rock known as magma beneath the Earth's surface. However, unlike their terrestrial counterparts, submarine volcanoes are found at the bottom of the ocean. In fact, around 90% of all volcanoes on Earth are located beneath the sea, although only a small percentage of these are active. So why do we even care about them if they're mostly dormant? Well, for starters, monitoring these volcanoes helps us understand the inner workings of our planet. By studying how magma moves and erupts beneath the ocean, scientists can learn more about the Earth's core and mantle. This knowledge can help predict eruptions on land, potentially saving lives and property. Submarine volcanoes are also a unique habitat for a variety of marine life. Despite the harsh conditions, organisms such as bacteria, corals, and fish have adapted to survive in these extreme environments. Studying these creatures can teach us more about the adaptability of life and the potential for life to exist in other extreme environments elsewhere in the universe. Additionally, these volcanoes play a significant role in the global carbon cycle. They release carbon dioxide and other gases from the Earth's interior into the ocean and atmosphere. Understanding the amount and timing of these releases can help scientists better model and predict future climate change. Finally, despite their danger, submarine volcanoes can also be a source of renewable energy. Some of these volcanoes produce geothermal energy, which can be harnessed to generate electricity. This clean, renewable energy source could potentially help reduce our reliance on fossil fuels and mitigate climate change. Now that we know why submarine volcanoes are important, let's take a closer look at what makes them so dangerous. One of the biggest challenges in studying submarine volcanoes is simply getting to them. Most submarine volcanoes are located far from shore in deep waters, making them difficult to access and explore. Researchers typically use ships equipped with sonar, which create maps of the ocean floor by beaming out sound waves at the seafloor and measuring the time it takes for them to come back. They can also use remotely operated vehicles, ROVs, which are unmanned robots that can be lowered into the water to explore shipwrecks and other underwater objects. ROVs are tethered to the surface, so they require a ship to operate and can only explore areas within reach of the ship's crane. In some cases, researchers may use autonomous underwater vehicles, AUVs, which are unmanned submersibles that can operate independently. AUVs can travel further and stay underwater longer than ROVs, and can be used to map large areas of the ocean floor. Scientists can also study submarine volcanoes using data from satellites that orbit the Earth. Satellites can track changes in the shape of the ocean surface, which can indicate the presence of a volcano or an eruption. They can also measure changes in the amount of heat coming from the Earth's surface, which can help identify areas where magma is building up beneath the ocean floor. Despite these technological advances, exploring submarine volcanoes remains a challenging and dangerous endeavor, but the risks are worth it, given the valuable insights that these missions can provide. So how do submarine volcanoes erupt? Well, much like their terrestrial counterparts, submarine volcanoes erupt when magma reaches the surface. However, due to the immense pressure and force of the water, submarine eruptions tend to be much more explosive than those on land. This is because when magma comes into contact with seawater, it reacts violently, causing a rapid increase in pressure and volume. The sudden expansion of gases and steam can lead to violent explosions that can be heard hundreds of miles away. In addition to the explosive nature of submarine eruptions, the molten lava can also flow outward, creating new land masses. Over time, these lava flows can cool and harden, forming underwater mountains and ridges. For example, the Mid-Atlantic Ridge is a massive mountain range that stretches for over 4,000 miles through the Atlantic Ocean. It was formed by volcanic activity along the Mid-Atlantic Ridge, a divergent plate boundary where two tectonic plates are moving away from each other. As the plates diverge, magma from the mantle rises up to fill the gap, creating new ocean floor and mountain building. When it comes to predicting when a submarine volcano will erupt, scientists have a tough job on their hands. Unlike their terrestrial counterparts, submarine volcanoes don't give off the same telltale signs before an eruption. They don't produce ash clouds or towering lava lakes that can be seen from miles away. Instead, scientists rely on a variety of methods to try to forecast when an underwater volcano might blow. One approach involves monitoring changes in the shape of the volcano itself. By using sonar and other technologies to map the volcano's shape over time, scientists can identify areas that are bulging or rising, which could indicate magma buildup beneath the surface. Another method involves measuring changes in the temperature of the surrounding water. An increase in temperature could signal that magma is getting closer to the surface. Additionally, scientists may monitor seismic activity in the area. An increase in the number or intensity of earthquakes could suggest that magma is moving through the crust, getting ready to erupt. And while these methods aren't foolproof, they are essential for keeping people safe and mitigating the potential damage caused by a submarine volcanic eruption. It's important to note that these eruptions are rare, but not unheard of. In fact, the youngest and currently active volcano in the United States is an underwater volcano called Axial Seamount, located in the Pacific Ocean off the coast of Oregon. The volcano is part of the Explorer's Outpost, a chain of underwater mountains that stretch for over 1,000 miles along the west coast. Axial Seamount last erupted in 1986, and scientists closely monitor it for any signs of activity. The potential consequences of an eruption by a submarine volcano can be significant. Eruptions can cause the release of large amounts of carbon dioxide and other greenhouse gases, which contribute to climate change. Underwater volcanoes can also trigger tsunamis, which can cause widespread flooding and destruction along coastal areas. And finally, eruptions can lead to the formation of new islands or the alteration of existing ones, which can have major implications for marine ecosystems. So what happens when a submarine volcano erupts? Well, it depends on a variety of factors, including the size of the volcano, the depth of the water, and the amount of magma released. In some cases, the eruption may be relatively small, releasing only a small amount of magma and causing minimal damage. However, in more extreme cases, submarine volcanic eruptions can be incredibly destructive. Take the 1883 eruption of Krakatoa, Indonesia, for example. This catastrophic event was caused by a series of explosions that sent massive amounts of ash and rock into the air. The force of the eruption was so powerful that it generated a tsunami that hit coastal areas thousands of miles away. The tsunami caused widespread destruction and loss of life, claiming the lives of more than 36,000 people. Another devastating example is the 2011 eruption of the Havre volcano in New Zealand. The eruption caused the formation of a new island, which ultimately ended up being named White Island. The island was initially uninhabited, but quickly became a popular tourist destination known for its beautiful scenery and geothermal activity. Unfortunately, in December of 2019, the volcano erupted again, this time claiming the lives of 20 people who were visiting the island. Finally, we have the 1980 eruption of Mount St. Helens in Washington state. While not technically a submarine volcano, this eruption provides a good example of the devastating power these geological formations can possess. The eruption was one of the deadliest in U.S. history, claiming the lives of 57 people and causing billions of dollars in damages. Submarine volcanoes are fascinating geological formations that play a significant role in shaping our planet. While they may seem like a distant and obscure phenomenon, they have the potential to impact our lives in big ways, from influencing local climates to providing homes for unique marine life, to generating renewable energy. Submarine volcanoes have a lot to offer. At the same time, they pose serious threats such as triggering tsunamis, releasing harmful gases, and causing widespread damage through volcanic activity. By learning more about these underwater giants, we can better understand the forces that shape our world and develop strategies for mitigating the risks they pose. Maybe one day, we'll even be able to harness their power for good, turning these explosive behemoths into a source of clean energy for generations to come.